Timbering plan execution is one of the most nerve-wracking day in the life of blast furnace. It is a blow in that moment when we wake up 1758 meter cubist. On the screen you see a glowing wireframe of our furnace with the hearth and the Bosch area highlighted in the orange. We are looking at the comprehensive logistic plan. This is not just about throwing wood in a hole, it's a strategic engineering exercise that determines the success of the next decade of operation. If we miss a step here, the thermal health of the furnace is at risk before we even tap the first iron. To get this right, we have to align on three core strategic goals, and these goals are defined in this subsequent slide. The strategic goals here are the things we have three jobs to do simultaneously. Look at these three icons on the screen. A shield, three rising arrows, and a flame. Goal 1 is hearth protection. We are using a coke pad like a mattress to catch falling timber so we don't crack the carbon wall refractories. Goal 2 is core permeability. Think of it like a building an exhaust pipe or a central chimney for high velocity gas. Goal 3 is the thermal preheating. We need high quality bone dry wood to get that central coke bed screaming hot. So these goals ensure the furnace doesn't just start but stays breathing and permeable from the day one. To hit this target, we follow a very strict clock, and those rosters or the schedules are very important. And these are, we should not forget, these are the critical path. So, how do we coordinate 192 hours of non-stop work? You look at this timeline, it's a blue to orange progress bar divided into four 48-hour phases or quantums. So, phase 1 is all preparation, pulling tires and setting up conveyor. As for phase 2 is concerned, is all about the big drop where we plunge wood into the center. Phase 3, where the manual labor kicks in for wall stacking. And finally, phase 4 is the finish line, tier finishing and closure. So this schedule keeps our team synchronized so we are not tripping over each other in the hearth. But before we move a single log, we have to talk about the Lego blocks of this project. Now, as you see the volume engineering for 1758 meter cube blast furnace, a scaling matrix, how much wood is enough? On the screen, there is a cross section of the furnace with our calculated projection in an orange box. We start with a 373 meter cube total lower volume. We subtract the coke pad, leaving us with a 313 meter cube net filling space. Then we apply our 0.55 filling ratio. That's math tells us we need exactly 172 meter cube of effective timber or roughly 7,600 individual pieces. Knowing this number means we would not run out of the fuel at 3 am when the furnace is half full. Now let's look at the specific wood type we are using to fill the space, and which is also very important because timber selection is the selection which is giving us a stability. So coming to the timber specification matrix, think of these our precision engineered building blocks. We have a table showing type A, B and C. Type A is our 1 meter primary block for the center. Type B is a 0.5 meter secondary block for the flattening layers, And type C is our 2-meter stand-up timber for the wall and the 2 years. So every piece must be pre-dried for the exactly 2 months. So if the wood is wet, it would not burn clean and you will end up with a mess of volatile residue in your initial slag. So wood is the main event, but it's not the only material on the list. So coming to the our ugly material requirement. So here the supporting cast that makes the firing possible. So look at these icons. Charcoal and sawdust act as our lighter fluid to catch the initial hot blast. We have cramp irons, which are basically heavy duty metal staples to fix the type C log around the taffels. Finally, 2.5 ton of waste timber. That's waste timber is a crammed into top gaps to act as a plug, preventing the heavy coke burden from dropping down and crushing our carefully built central chimney. Now let's go step by step starting at the very bottom. So step 1, the cook pad foundation. Before the first log is dropped, we need a cushion. Look at the diagram. There is a bright yellow layer at the bottom of the hearth. That is our cook pad, charged to 1.3 meter deep, right at the taffel level. Worker center after the first drop to flatten it out perfectly. So these pads protect our expensive carbon floor from severe mechanical impact of 40 kg logs falling like a spears from the 2-year level. So once the floor is protected, we set up our entry points. So equipments and entry logistics. How do we get so many logs inside? You use a clock face strategy. On this circular diagram, you see 8 tiers removed to make room for the conveyors. Tier 11 is strictly for the humans, that's the ladder access. Notice the clearance rule in the box. Conveyor must protrude more than 2 meter inward so that these ensure the wood strike that center coke pad and doesn't accidentally smash into the delicate brick wall on its way down. Now we start the actual filling process. So step 2, center plugging and wall adherence. So this is a two-phase dance. On the left, phase A is the center addition, dropping the locks from all 8 conveyors into a mountain in the middle. On the right, phase B is the wall adherence, where workers manually move those locks to the refractory walls, stacking them upright. Center plugging protects the brick from the impact while wall stacking prevents dead zone where gas can bypass the wall later. As the wood pile rises, we reach the most critical mechanical junction. So step 3 is the tier leveling and the mechanical protection. When the wood reaches the tap hole, the throwing stops. Look at this technical cross section of a taffel pipe. We use those long type C timbers and cramp irons to build a rigid wooden wall around the pipe and the tier nozzles. We also seal non-essential tiers with clay. This secures a drainage path for initial liquid so they can reach the taffel without drowning the tier nozzles. So we are in the home stretch of feeling. Now coming to the step 4, finalizing and accelerant charging. The furnace is now full. As seen in this cross section, we place 10 kg sacks of charcoal in front of every open tuyer to catch the fire. We position sawdust at the 0 to 180-degree tuyers for blow-in ceremony. Finally, we ram that 2.5 ton of waste timber into the top gaps. These final staffing ensure the permeability we have worked so hard to build is not crushed by the weight of the coke and overburden coming next. So none of this happens without a massive team effort. So coming to the shift logistic and four stage manpower deployment, which is one of the important aspect. So who is doing the work is always important. So look at these interlocking gears. We have 32 workers per team in a two team rotation, one working, one resting. We deploy them in four stages from the initial coke flattening to the precision cramp iron work at the finish. So this rotation prevents worker fatigue, which is when most accident happens in the cramped, hot environment of the hearth. So speaking uh, mm, of accident, let's talk about our red lines. So critical safety gateways, total energy isolations, that is LOTO safety. That is LOTO. So safety is not a suggestion, it's a gate. So before anyone enters, the furnace top temperature must be below 50 degrees centigrade. This is must not forget. So look at the lock out, tag out checklist. On the right, nitrogen valve closed, steam closed, and the top bleeder open to vent pressure. Without this isolation, a simple wall leak could turn the furnace into a death trap for the 32 people inside. And once they are inside, the rules change again. So, coming to our next slide, which is on a critical safety gateways, fire prevention is must and spatial discipline is required. So this is a zero tolerance zone. No matches, no lighters, and strictly no smoking in the cast house. So you see the workers in the diagram. The rule is do not step over loose timber. Always step on secure flat surface. A simple spark or the collapse wood pile inside a furnace full of dry timber and charcoal is a disaster we cannot afford. So, we have done the maths, the labor, and the safety checks. So, in summary, readiness for the blow in. Here we are. Our 1758 meter cube furnace is timbered to exact volumetric specifications. The hearth is protected and the central chimney is ready to breathe. On the right, you see the blueprint transition into a roaring burning furnace. Because we followed this 192-hour blueprint, we are not just crossing our fingers, we are launching with the highest possible thermal stability. Technicians, we are ready for the blow in.